Would you believe if we tell you that in 2020 there were more than 13,000 train accidents across the country, killing nearly 12,000 railway passengers, according to a report by the National Crime Records Bureau? That is, 32 individuals die every day in our country through railway accidents. The report also shows that 8,400 or about 70% of these railway accidents last year took place as passengers either fell off the train or came in the way while crossing the railway track. And majority of the deaths of the rest are from direct train collisions or head-on collisions and from derailment. Sadly, these are the statistics from a period when 45% of the passenger trains in the country were not being operated due to the coronavirus pandemic. So from the statistics, we understand that 70% of deaths are due to accidents, mainly from careless voluntary actions, and that can only be changed if every individual starts respecting and obeying the rules set forward by the Indian Railways while traveling across and crossing the trains. Derailing can also be managed with proper inspection and maintenance of railway tracks and trains. But what about these head-on collisions? Trains travel through specifically designed and designated paths or tracks and hence should be easy to manage as all routes are already known. Then, why do these collisions occur? That's where we are wrong. Rail traffic control differs fundamentally from all other modes because the operator of the rail vehicle must exercise virtually all vehicle control through changes in speeds. Rail's principal mechanical advantage is the low friction between the wheels and the rails. This allows for efficient propulsion of the vehicle. Unfortunately, it also causes rail's chief control problem, very long stopping distances. In virtually all stations, the rail vehicle operator must anticipate events very far in advance in order to take appropriate action. Hence was developed the automatic train protection or the ATP system known as Kavach, which literally means armor. Kavach is promoted by the railways as the world's cheapest automatic train collision protection system and is built to help the railways achieve the goal of zero accidents. It is designed to bring a train to a halt automatically when it notices another train on the same line within a prescribed distance. The Indian Railways conducted a live demonstration of Kavach on March 5, 2022 for trains near Secunderabad with both Railway Minister Ashwini Vaishnav and Railway Board Chairman V.K. Tripti on board in two locomotives coming from opposite direction on same track. But both the locos stopped automatically at 380-meter distance from each other and avoided collision because of this new technology. The collision system, also known as Train Collision Avoidance System, has been under development since 2012. The Kavach system adds radio frequency identification device RFID trackers in every locomotive along with RFID in signaling systems and rail tracks. These devices communicate with each other to constantly track the location of every locomotive, send out alerts to drivers, and to even control the braking system of locomotives. Additionally, the devices also alert the drivers about the information regarding railway signals on the tracks ahead, crucially important in low visibility weather. The system is already tested and implemented in many European countries, costing about 1.5 crore to 2 crore per kilometer to install. But the Kavach developed in India by Railway Ministry's Research, Design and Standards Organization in collaboration with other partners will cost comparatively much less, that is around 40 lakhs to 50 lakhs per kilometer. Announced in the 2022 Union Budget as part of the Atmanirbhar Bharat initiative, 2,000 km of rail network is planned to be brought under the indigenous world-class technology Kavach for safety and capacity augmentation in 2022-23. So far, Kavach has been deployed in over 1,098 route kilometer and 65 locos in ongoing projects of South Central Railway. Further, Kavach is planned to be implemented on Delhi-Mumbai and Delhi-Howrah corridors, having a total route kilometer of around 3,000 km as part of Mission Raftar project for raising speeds to 160 km per hour. All of us must appreciate government's decision to develop and implement this technology within our country, utilizing brilliant young minds of Outtown. The result is right before you in form of cost difference from the already used same technology around the world. We hope in future we develop every technologies needed for our country in the same way, utilizing our own resources, and at the same time we wish Indian Railways our best in achieving their goal of zero accidents in future.